Hi class, welcome to Math is Fundamental. Today we're going to be talking more about slopes of parallel and perpendicular lines. So getting started, let's look at an example. So plot the points and find the slopes of the following two lines using the same set of axes. So we're going to color code them. I'm going to do one in blue and I'm going to do the other one in red so that we can see the difference of the two. So the first one, I have my axes. We want to label our axes, x and y. And I have -1, 5. So -1, +1, 2, 3, 4, 5 is going to be there. And then 2, -4, +2, 1, 2, 3, -4. And again, I'm not writing all of the numbers on my axes, only writing the ones that I use. Save me some time. All right, so here is going to be, let's see if I can do this somewhat straight. Pretended straight. All right, this is going to be L1. Oops. Well, I used the wrong color, so let's switch. This one's going to be red. All right, and then this one's going to be blue. All right, and then for our L2, we have -3, 2, -1, 2, -3, +2. All right, and then -1, -4, 1, 2, 3, 4. All right, so here's this one. And this is going to be our L2. So if we look at those two lines, and I know they're not quite perfect. Let me straighten that out just a little bit. All right, if we look at these two lines, we can make a conclusion here that oh, I'm not done with my example. I'm so sorry. So it said plot the points and find the slopes. Let's find the slopes. All right, so for L1, our slope M is going to be, remember, slope is y2 minus y1 over x2 minus x1. We learned this in the last lesson. All right, so we use our points. And again, if you're still struggling or getting used to slope, you can always write the letters x1, y1, x2, y2 to help you organize your work. So here, y2 is going to be -4 minus y1 is 5 over x2 is 2 minus x1 is a -1. All right, so simplifying that, I have I'm just going to put it over here. I have -9 over 2 plus 1. Remember, negative makes a positive, which is 3. And simplify that to -3 or -3 over 1. You can leave the over 1. You don't need to have it there. All right, let's look at L2. So L2, finding my slope. Again, I have x1, y1, and x2, y2. So my y2 is going to be -4 minus y1 is 2 over x2 is -1 minus a -3 for my x1. Simplifying this, I'm going to have -6 over -1 plus 3. I'm going to write those. I don't want to do too much in my head here. So it's going to be -6 over 2, which reduces to -3 over 1. Now, if you notice, those two slopes are the same, which makes those lines parallel. So our conclusion is that in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. So we can use that graphically if we find the slope. We can look at an equation and look at the slopes to see if they're parallel. We can use it lots of ways. All right, next piece of our lesson is going to be very similar. So let's do this equation, or sorry, this example. We have the point 0, 1 and the point 2, +2, -2. All right, so here's my L1. And I want to label that L1. We always label our lines. All right, and then L2, I have 0, -2, and 1, 2, 3, 0. All right, so here is my L2. Okay, now if we look, it looks like those lines are perpendicular, but let's just find the slopes to double check. So here we have slope of, this is the blue one, L1. So y2 is going to be -2 minus y1 is 1 over x2 minus x1. All right, so that's going to be -3 over +2. And then let's find our slope for L2, color coding again. We have y2 is 0 minus y1 is -2 over x1 is 3 minus 0. So now I've got a +2 over 3. So if we look, these slopes are definitely not the same, which makes sense because the lines are not parallel. These lines are perpendicular. They meet at a 90-degree angle. So we can make a conclusion using this information. In a coordinate plane, two lines are perpendicular if and only if their slopes are opposite reciprocals. Now, opposite reciprocals, the opposite means that you're going to switch signs. So switch your positive or negative. And reciprocal means you're going to flip the fraction. So nice math jargon there. Opposite reciprocal, you switch the signs and flip the fractions. All right, let's close with an example. We're going to write the equation of a line that is perpendicular to this equation, y equals 1/5 x plus 2, and contains the point 15, -4. So graphically, now I'm just going to really quickly sketch this. Graphically, what this would look like is I have some line 1/5 x plus 2. So let me start at +2, and I'm going to go up 1 over 1, 2, 3, 4, 5. All right, so here is my line that they're telling me that I need to be perpendicular to. And it has to contain the point 15, -4. Okay, so if I go all the way out here, again, I'm just going to sketch this really quick, to 15 and down to -4, I have to contain this point here, 15, -4, and I need to find the equation of the line that's perpendicular to our original line going through this point. So I need to find the equation of that line. So here, find the equation. Now graphically that might be a little difficult, so we're going to do it algebraically. Okay, so first thing we do is we're going to find our slope. So our slope, and I want a perpendicular slope. So remember, our slope of this equation is 1/5. So our perpendicular, and I'm going to use the sign for perpendicular, slope would be -5 over 1, or just -5. So we're going to use this as our m value in our equation. Now I can use my point slope form. I have a slope and I have a point 15, -4 on my line. So I'm going to use point slope form. Point slope equation. So I have y minus, my y for my point that I'm using on my line is -4. So -4 equals my slope, which is -5, times x minus my x value, which is 15. All right, and then we just need to simplify a little bit. So we're going to have y plus 4 equals -5, x minus 15. Now we have to go back to the instructions of the problem, because if it says specifically what type of equation I need, we might have to change this. If it said in slope-intercept form, well, this wouldn't be quite enough. We'd have to change it a little bit so that it was in the right form. But this equation, this example says just write the equation of the line. It doesn't say what type of equation, so I don't need to do any more work than I've already done. I have the equation of the line with a perpendicular slope to the one I was given, and it goes through the point 15, -4. All right, and that concludes our lesson for today. Thank you for watching, and remember, math is fundamental.